Hi, my name is Amedeo Beretta, and in this video we're going to see how to model and rig a camera iris, also known as a diaphragm shutter. First of all, we are going to do some research and we're going to try and understand how a camera iris actually works, because it's not as straightforward as one would think, although it's also not that difficult if you think of it. Then we will see how to model the individual components so that they are easy to rig, and finally we are going to see how to rig them. So if you are interested, feel free to follow along. Camera blades come in a variety of shapes and sizes, and in my opinion that doesn't make it very easy to start this task. On the other hand, that means that we have plenty of diagrams we can take from to understand how the camera shutter works. Also, there are plenty of videos explaining both the assembly and the functioning of a camera iris, which is great for us. I am recording this video because I am working on a short movie with some of my students, and one of the things they need to do is to model a camera iris. The look we're going for is this one with 7 blades featuring this nice curvy line following the blades as they close along. It is indeed important to start with a clear goal in mind to know exactly which kind of model you're building. Overall, I noticed that it doesn't really change too much if you have 7 blades or 20 blades. It doesn't quite make that much of a difference for the purpose of this video. So let's have a look at the way camera diaphragms are built. So I'm looking at this YouTube channel named Iris Calculator. There's a video named Spaghetti Iris Dismantled and Reassembled, and this video makes it very easy to understand how the camera iris is built. This is a very basic camera shutter, but it works very well. And the first thing I notice in here is that the camera blades seem to be built inside the rim, and there seems to be a common feature for which the root of one camera blade, its rotation pivot, seems to be always above the camera blade that is preceding this current camera blade. You see this pivot point in here is always above the previous camera blade, and so forth, and so forth, and so forth, and so forth, and so forth. Conversely, the tip of a camera blade is always resting underneath the next one. So that's something I will have to keep in mind because it will influence the way I will model this part. Also, I am noticing that when the blades are in their rest position, they are perfectly aligned to the inside of the rim that holds them together. This is a good thing to know. In fact, you see how well they fit into the rim. As I mentioned earlier, there are plenty of different shapes for the blades. In this channel named DDP Photo Tips, you can see one, for instance. But one feature that is often common to all these blades designs is that there is a fixed pivots. You see these little dots in here around which the blades are actually rotating. A third thing that I'm spotting is that the tips of this blade are resting against the next blade. So as the blades close, these parts, the tips, are likely to be deforming more due to the cumulative effects of all the blades resting onto one another. That means that we either aim for a rig that also addresses that deformation, or we go for a simplified version. For the project I'm working on, I am really interested in replicating the outside look of the blades, however, so I will not be managing the deformation that happens on the inside. That means that while modeling, I will have to play some tricks to make this thing work without additional rigging. In my opinion, the fact that those blades are compressed against one another and that there is some deformation on the tip is also one of the reasons why those blades need lubrication. But I am no engineer, so take this with a pinch of salt. I could use blueprints, but I can also take a snapshot of this video to make modeling easier. The snipping tool from Windows is an ideal tool, so I'm going to click on New, and I'm going to just drag the selection around this. Then I'm going to open up PureRef and right-click on it. I can go under Paste and paste the picture. And you see that now I have the same picture that I snipped from YouTube, but it's on an overlay that is above everything else. And I can control the transparency of this picture by pressing Ctrl+ and Ctrl- on the keyboard. PureRef is a great tool for modelers and anybody working in CG really, because it allows you to build canvases of pictures just by dragging them onto the canvas. And now you see that I can move the pictures around and I can start building a bunch of references from whichever picture I find around. It's super easy. See that? There you go. That makes it a lot easier to work. And this canvas can be saved as individual pictures or as a single PureRef file and shared with people working with you. Now that I have my reference picture, I can just place it so that it's big enough for me to be able to appreciate the details and the scale of things. And then I want to make sure it always stays on top, because you see as I click in Maya, it goes under Maya. So I right click on the picture and under mode, there is always on top. The other problem is that this picture is covering Maya a bit too much, so I can hold down Ctrl and minus until the picture becomes a bit more transparent. And this way, you see, now I can see Maya and I can see the picture. Also, I don't want to be able to click on the picture anymore because that's going to be used as my image plane in there. So I'm going to right click and go Mode, Transparent to Mouse. Remember that there is a shortcut to go back from that, Ctrl T. I click on OK, and now whenever I click in Maya, you see that the picture is there and it's a lot easier to model. I will start by going into the top view and create the rim that will hold the blades in place. For that, I will need a pipe, which I can scale up. And there you go, we got lucky. You see the pipe is already more or less the right proportions. We don't really need to be super precise in here in terms of how big things are, but we certainly need to make sure that things are aligned. I'm going to give my pipe a number of subdivisions that is a multiple of 4 just to make it easier to model at a later stage, and just so that you see I have diameters right in line with the main axis of the grid. That makes modeling a lot easier. So now it's time for me to model the blades. I gotta be careful here because the reference I picked has only 6 blades, but the model I want to build has 7. So it's better if you find a reference with exactly the number of blades you have. But I will show you that even with that, we can work out some tricks to make sure that we can even design the blade design as we go without having to sweat too much. So if the blade we are going to build is 1 of 7, it will be slightly shorter than the blade we have in here. It doesn't matter too much. One thing I noticed, remember, is that the inside of the blade was supposed to be perfectly aligned to the inside of the rim. So I wonder if instead of building a blade from scratch, I couldn't reuse the geometry of the rim. And in fact, I will do exactly that. I will duplicate the rim, I will hide the original one, I will select the faces of the rim that may build the blade, and then I will invert the selection and delete the faces. Let me lock the top view and then let's go back to perspective, and you see I have my blade done already. And it's going to be hopefully perfectly aligned to the inside of the rim because it shares the same topology and the same shape. However, at a certain point, I will have to extrude out the inside and outside edges of the blade to provide some hard edges as I turn the blade from a flat plane to a three-dimensional object. So I think keeping the edges perfectly aligned to the rim right now is not the best solution. One thing that I could do instead is I could select the edges like I just did, move the pivot of the transformation to the center of the rim and just scale them out to give me enough room to do an extrusion at a later stage. This way it will be a lot easier later on to control the model, I believe. And I can do the same with the outer edges. Move the pivot of the selection right there at the center of the grid and scale them down ever so slightly. This way I will be able to extrude them later. It might not be entirely clear to you now, but you will see that at a later stage its utility will become obvious. So now that I have my blade, I think it's already time for us to test it out. I think one thing that I could do with the blade is to move the pivot right where it is on the blueprint, right there. So now as I rotate the blade from that point, you see that sort of works already. So let's see if building the other 6 blades will make this shutter work already. It doesn't make sense for us to build the other blades manually. Also, it would be a lot easier for us to work if we could edit the shape of one blade live and have the other blades automatically update their shape as well. So to do that, we will use instances, which we will not keep until the end of the project, however. Now, to make other blades, the procedure would probably be to group this blade, and you see that the group goes at the center of the grid, and it's always a good idea when you model hard surface, in my opinion, to stay at the center of the grid, or in any case to stay aligned to the grid. And this way, if you think of it, I have a group, and if I duplicate the group and rotate it around, you see that I'm building blade after blade after blade. Right now, however, I don't want to do it manually. Right now, I want this procedure to happen on its own. So I will bring in the calculator. I have 7 blades. A full sweep of a circle is 360 degrees. 360 divided by 7 and 51.42857 and so forth is the amount of rotation I have to do every time I duplicate the blade. Luckily for us, in 3D software, you can easily duplicate stuff. So we want to go Edit, Duplicate Spatial Options, and in here we want to think about a couple of things. First of all, when I duplicate the blade, on which axis should the blade be rotating? And it seems to me that the axis is rotate Y. That means that when we duplicate the object, we need to rotate on Y. So I'm going to copy the value of rotation that I took from the earlier maths, and then I'm going to paste it right here. How many blades do I need? I need 6 more blades. However, remember that one of the requisites was that we should have been able to edit one blade and have all the others follow suit. To do that, we have to do an instance copy instead of a regular copy. So with the group selected, I'm going to hit apply, and now I have 7 blades. And if I go and grab the original blade, which I will name original so that I won't get mistaken, when I rotate that blade, you see that it starts making sense. In fact, one thing that I could do is to set a key at 1 on that blade, go to another frame, and set a key until the blades are fully closed. There you go. If you want to zoom in on a locked camera, one thing that you can do is hold down the backslash, the one next to Z on a British keyboard, and just zoom in and out like you would do with a normal camera. And this way, you see, it becomes a lot easier to check if you're actually closing the blade. So I'm going to maybe increase the rotation just a tiny bit until I get to a fully closed blade. If you want to go back to the unedited viewport, you just hit backslash again and you're back to the old camera. This is very useful because that means that now we can model the blade and check its functioning without having to be distracted by having to move it, rotate it, or animating it. Now, if I grab any vertex of my blade, you will notice that all the blades are now working. There you go. And you see that that becomes a lot easier to work with. But for now, I think I can just hide the other blades because that is getting a bit too complicated for me. So let's build a model. Please notice that at this stage the model will be planar and I will be using the rim shape as a reference. I can maybe use soft selection to make this process a little bit faster, and you see I will just line up the vertices to the topology underneath just to keep the geometry clean. I don't think that I need this face, so maybe I can delete it. And since I'm planning this shutter to be seen from the outside, I don't care too much for the shape we have on the outside of the blade, but I'm really interested in keeping the inside shape clean. There you go, and now the shape is sort of working. If I want to see the effect, I can just unhide all the duplicates and I can go back to perspective and see how this thing works. At this stage, having the reference visible from PureRef is no longer useful, so I can just close PureRef for now. Now this rim is a bit too thick, so I'm going to make it a lot narrower. And I'm going to bring it up here. There you go. And right now the problem we are having is that all those blades are intersecting massively, you see? That's a bit of a problem, and it also makes it hard for us to replicate this shape in here because this shape in here doesn't seem to have all the blades on a similar plane. So here's when I have to go back and I have to think about it. So how do I do it? And this trick will be informed by my previous observation that the tip of a blade is always resting above the next blade. But the origin of a blade, the root, is always resting underneath the next blade. That means that these blades by default are at an angle to one another, although a very small one. Now things are a bit confusing because we have two objects with the same material, so it would be good to just give a new material to the rim so that we can color it in a different way and we can start seeing things a bit clearer. I'm also going to give the blade a different material. You never really want to change the color of the default Lambert from Maya, so I have made a new Lambert for each part. And now you see it's a lot easier to understand what goes on in there. So we were saying this blade is resting at an angle. So I guess that means that if I select these faces and I rotate them up from, say, this pivot and move them up this way, if I now show the other blades, the duplicates, they will no longer be intersecting, you see? And as they close, hopefully they will close quite alright, which seems to be more or less the case in there. To appreciate the gap between the blades, I really suggest that you create a light in the scene, just so that when you hit 7 on your keyboard and you orient the light and you enable the shadows, and maybe ambient occlusion in the viewport, you can better appreciate you see the gaps between the blades, because wireframe can be deceptive. So now you see that we are onto something, we start to be onto something. Please notice that earlier on, I've just rotated the faces, not the geometry, because the geometry you see carries keys on rotation, so I'm not going to rotate the geometry. I could have rotated the geometry if I created another group on top of the geometry itself, and if I would have given that group the same pivot of the blades. Right now, I'm kind of okay with the solution I've adopted. I can make the gap between the blades even bigger, and again, if I unhide the blades, you see in here, I start to see a bit more of an effect, which is going to be nicer when rendered, of course. The problem with this is that since we are not accounting for the deformation that happens in the blades as they close, we are going to have more thickness near the root of the blade and less thickness towards the center. But that's a side effect I am happy to withstand. If you want different shapes, you can still grab one vertex from any pose you are in and just move the vertex around, you see, until you get to the shape you want. This is very useful because that means that we can really change, you see, the shape of everything with a single vertex very easily indeed. So for instance, I can grab the last two faces of each blade by just selecting a single blade, and I can rotate them ever so slightly, you see, to increase the thickness of the gap between the blades as they approach the center. You still gotta be careful not to bend the faces too much, because that will create a wobbly blade, of course. So now we want to have a look at the whole animation in there, and you see there is some intersection going on at that level, but that should be hopefully relatively easy to fix, because maybe I can just grab this blade and lower it a little bit. There you go, and you see that now it all works very nicely. Now that's sorted, and hopefully there aren't many intersections that will be seen in render. And now that we have the flat blade, it's time for us to build the high-res model out of it. So I'm going to go back to the original blade. This is a bit confusing because I see all the other blades now, so I really need to hide the other blades for now. And for this blade, remember, it needs to have a thickness. The problem with that is that if I just grab the faces and extrude them out, say this way, the moment I'm going to smooth this shape, you see that it looks like a banana or a boomerang. I can't quite control the topology of the edges because I do not have the supporting edge flow. So this extrusion was a bit premature, right? Instead, I could select all the edges, I could extrude them out using offset as an attribute that I'm moving. I want to make sure that I don't go past the rim. I can maybe smooth both shapes to see how this works. And you see that now the blade is perfectly aligned to the inside of the rim because we use the topology of the rim to achieve this effect. On top of that, we have a very useful edge flow that we could use to control the hardness of the edges once this shape becomes a 3D shape. Every time you change the shape, you really need to make sure that you don't generate intersections. And you see that in here, we do generate a little bit of intersections. So maybe I could grab those faces here at the end of the blade, lower them ever so slightly to prevent further intersections. And you see that now everything works just fine. That's great. And make 3D objects out of these blades. So I'm going to select all the faces and extrude them. There you go. That gives me the thickness, you see. And now this is working quite nicely. And I can control the hardness of the edges by increasing the divisions along the depth of the blade. You see in there? Very easy to make. And then if I need to further control the hardness of the edge in here, I have the perfect edge flow running around the whole geometry. And you see that I could go through that operation with a single click. So now I have a very good shape in there, very precise deformations, and everything works very well. And on the opposite side, we do have some intersections, but since we will never see them, it doesn't make sense to fix them. We could have fixed part of those intersections by working a little bit more on the flat blade before extruding it out. Now that we have all of our parts, it's time for us to start rigging. First of all, it's a good idea to put both the rims onto a layer and template the layers so that they don't get in the way while we work. And then remember, we duplicated with instances so that we could easily tweak the shape and see the result, but we don't want to be tied to those instances, which are only a source of problems as far as we are concerned. So we're going to delete them, and we are going to duplicate the original group containing the blade geometry instead without using instances. So we're just going to do a regular copy operation with the same exact values. So that's going to be our first operation. And you see that now only the original blade is rotating, the others are standing still because they are no longer connected to it. Then we need a joint or a locator per each one of these blades. That's very easy to make. First of all, I will create a locator at the position of the blade. Right now I'm doing this with a tool, but in Maya you can do it with Maya Natives tools. If you select the locator, then the shape, and you can go under modify, match transformations, match all transforms. That is also going to match the scale that we don't really need right now. Speaking of which, it would be a good idea to freeze the scale on all the blades. In order to do that, however, it would be also a good idea to remove the animation from the original blade. Please make sure to do so when the blade is in its resting position. With the animation deleted, I can now finally freeze the scale. Now I have no longer any animation there, but I have the locator, and I can maybe create a joint at the position of the locator. That's really easy to make, but you see that the joint and the locator are a bit too low if compared to the blades. The important thing is that we don't change the pivot this way, but we can certainly change the pivot vertically so that it's a bit better aligned to the blade. That won't change our rig at all. And now I need to duplicate this joint around just like I did with the shape, and I can achieve the same effect by grouping the joint so that the group will have a pivot which is centered, and running a duplicate spatial on the group, and now you see that I have all of the joints I need. Now I can unparent them, and now it really is a matter of connecting the joints, but maybe I can rename them. So I will select them in a precise order from the first to the last, and I'm going to give them an increasing number at the end, an integer, you see that? And then I'm going to give them a suffix You really need to be very quick at renaming stuff in Maya because that's an operation that you really want a computer to do. You don't want to go through every single piece and rename them manually. That would be a waste of your time. So this is the joint, which is going to be the pivot, and this one is going to be the blade that is going to rotate with that joint. So maybe it's a good idea to select the blades with the same exact order we used for the joints and run the same exact naming convention. So blade underscore index offset, we start with 1, padding 2, and now we have 7 blades in there, which we can unparent. We don't need them anymore to be under the groups. The groups were just there for the blades to be easily duplicated, and I can add a suffix and call this thing geo, because at the end of the day, that's geometry. There you go. So now I can select a joint and its respective blade, and I can go skin, bind skin, and I can do the same, hit G, and so forth until all the blades will be skinned to the respective joints. So now if we rotate the joint on a single axis, we should have exactly the same behavior. You can easily script a rig like this one, by the way, so that you don't have to do it manually. And I suspect you can easily build a shutter generator if you think of it. Now we need a controller to animate those joints. So I'm going to create a NURB circle and make the shape not perfectly round so that we can easily understand when the shape is rotating. Something like this, for instance, will work for me. And now I need to understand which axis the joint is rotating on. And if I move the joint this way, you see that I'm rotating around the Y axis there. And you see that the control rotates the same way on Y. So now we have a variety of methods to connect those joints to the controller. One method could be to just do a direct connection for which the rotation Y of the controller is driving the rotation Y of the joint. And you see now they move together. That's one way of doing it, but you have to do it for every blade. Another way of doing this could be to operate an orient constraint between the two. So I could orient constraint only the Y axis of each joint to the control. So control selected first, joint next, apply, and now if I rotate the controller, you see it works. And I guess I could do the same for every single joint. So controller first, joint next, repeat, joint next, repeat, and so forth until I'm done. Now I can bring back the rims, animate the controllers, and see how it works. I can assign a different material to every other blade. There you go. And now we have our perfectly aligned iris. It works really well. It looks really nice. And I hope you have found this video useful. If you have, please like, subscribe, and hit that bell. Have fun!
Very good, blood circulation.